All right, today we are recapping writing methods, going a little bit deeper in detail. So, very brief recap of what methods are. Methods are blocks of code that we can call repeatedly, and that's going to allow us to reduce the amount of code that we need to write in our in general, because we can call this block of code anytime we need to access it. The signature for a method, which is going to define everything about that method, is going to require four things. Thing one, an access specifier, so public or private. We learned about those day one of this unit, so we should have a better idea of when we want to use one or the other. Thing two, a return type. If our method is going to be returning a value, we need to specify what type of value we'll be returning. If it won't be returning any value, we can use the return type void and simply return nothing. Thing three is a name. We need to give our method a name so that we can call that name anytime we want to access that chunk of code. And our last thing is a list of parameters. We need to have any information that our method is going to need in order to operate correctly. So as an example, we have our public void set width with an int new width. Those are all the four different pieces of our method signature. The only one that is truly optional is the list of parameters, although we do need that pair of parentheses regardless of whether or not they are empty. All right, so if you remember back to when we first learned about methods and parameters, our formal and actual parameters. Formal parameters are the variables listed within the definition for the method. So my int new width, that is my formal parameter for my set width method. I'm declaring it, and when I call this method, this formal parameter will be initialized with the value of the actual parameter. Actual parameters are the values we are passing to the method when we call it. So our new width is our formal parameter. That is super not correct because things got moved to the next line. Our actual parameter, that's the value 6. Our actual parameter is used to initialize our formal parameter new width. Feel like this is pretty self-explanatory, but the types of your parameters do not need to match the return type of the method. So in this example, I have my string method. It's going to return a string, calling it string number, and it takes an int as a parameter. If my n is equal to 1, I'm going to return the string 1. If n is equal to 2, we're going to return the string 2. If n is equal to 3, we're going to return the string 3, else we're going to return a number. So we're going to return the word version of the number 1, 2, or 3, or if it's any other number, I'm just going to return the word number. So on the right side, my int my num equals the number 2. I'm going to say my word num equals the string number, call in my string number method on my num, and then I will print out my word num. So once again, my string and int, those don't need to match, but the types of my formal and actual parameters, so my int n and my num, those types do need to match. Otherwise, we're going to run into errors. We always want our types to line up. So our value of our actual parameter is going to initialize our formal parameter. So the value is 2. We're going to use that within our method. N double equals 2, that is true. So we're going to return 2. We're going to send that back out. Our word number is going to equal the string 2. So when I print my word num, we're going to see the word 2 printed out. When our actual parameters are primitive, changes within the formal parameter are not going to affect any variables that we are passing as actual parameters. So when I pass my num, nothing is going to change within my num when it's been passed as a parameter to my word num, or to my set number, string number method, excuse me. Even if the variable n were to change within this method, nothing would happen to that variable my_num. However, when our actual parameter is a reference type, so for example, a rectangle, the formal parameter will be initialized to be an alias of that variable. So any changes that are going to happen to it will be reflected outside the method. So if I make a method called resetRect in my main in my myprogram.java class, it's going to accept a rectangle named r as its parameter. I'm going to call r.setWidth to 0, r.setHeight to 0. I'm going to set my rectangle to essentially be completely spaceless. It's going to be empty. My rectangle, my r, equals a new rectangle with width and height 5. I'm going to print out my rectangle. Then if I reset my rectangle and then print it out again, we see width, height 5, width 5, height 5. If we call our resetRect, we're going to reset both of those values to 0. And if I print my rectangle again, I get width and height are both 0 now. So changes within this method did affect my rectangle outside of the method. If we implement this code in myprogram.java, like I just had shown, we need to call those mutator methods for our width and height values for the rectangle. However, if I implement this inside of rectangle.java, we do not need to call those mutator methods anymore. We'll actually be able to access the private data of a reference parameter as long as it's the same type as the class that we're currently in. So if I build my resetRect method inside of my rectangle class, I no longer need to call my accessors or mutators. I can just say that rectangle r, dot width and dot height equal a specific value. Or I can access them without needing to call the accessor methods. Now, this only works if I'm in the rectangle class. If I try to do this notation outside of the rectangle class, I'm going to run into an error because those are both private outside of the, they only have access within the rectangle class. So if I try to access them from outside in this manner, we're going to hit an error. So like I said, if this was tried, this notation specifically in myprogram.java, we would get an error saying that both of those instance variables are private to our rectangle class. In general, it is good programming practice to only modify objects within methods when that's a required feature of the method. So when the express goal of the method is to make a change to an object, then it's okay. However, generally we want to avoid doing that because otherwise we can potentially cause confusion in anyone trying to use our class. If our objects are just being changed wherever, whenever in random methods, we can potentially confuse users. So we want to expressly tell people this is when this object is going to be changed. Otherwise, we're just going to be using this object, using the values within it. All right, any questions on what we learned today? It's all fairly recap stuff. All right, then that is it for our lesson. It's a nice short one.